Hello, everybody. Thank you for coming to our presentations for our Weber Lake camps. Last week, we had a few campers out with us at Weber Lake where they were conducting research about various aspects of the ecosystems. We had groups investigate soil quality, water quality, some who investigated toads, so all very exciting things. My name is Bryn, and I'm the camp director for Headwater Science Institute, and I'm very excited to welcome a few of those groups today to present their topics. So up first, we have Claire and Maddie, who are giving a presentation about water quality. So here they are. Claire and Maddie, you can take it away whenever you're ready. Claire and Maddie seem to be having technical difficulties. So Amelia and Noah, if you guys are ready, I'm going to add you guys and you can go ahead and start your presentation.
Okay. Noah, do you want to share your screen?
I'm doing that right now. Give me a second. Give me a second. It's just loading. Okay. Do you see it?
No. Bryn, do you have to accept it?
I don't think so. If you guys want to send me your presentation, I can share it.
Okay. What's your email?
I'll type it in the chat for you guys.
Okay, I sent it to you.
Okay, cool. I'm going to share that then. Okay, go ahead.
Okay. So, hi, my name is Amelia, and I worked with Noah for my project, and we decided to research how human products affect water quality, like sunscreen, lotion, and bug spray. You can go to the next slide.
When we first came to the camp, there were so many mosquitoes all the time, so we're constantly applying products like bug spray and sunscreen, and we also had quite dry skin, so we had to apply lotion. But then this sparked an idea in our minds, and we thought how we could test the bug spray, sunscreen, and lotion in the water to see how it would affect it. And we chose a couple different places to compare it to as well. And then we thought we might try and test it for specific ingredients and the effects it had on the water, but we weren't exactly able to since we didn't have the right materials. And then we modified our question down to the one we had now, and it showed us how the levels of the water were changing.
So, for our research question, we chose the question, how do human products affect water quality? And after thinking about this question, we came up with our hypothesis, and we believe that the outcome of our project would lead us to find that different human products like sunscreen, lotion, and bug spray would change pH and conductivity levels in the water that we tested near us.
We mainly used the scientific method because it allowed us to get correct data that we needed, and it also allowed us to stay focused to create a better outcome. We used pH tester, which measures the hydrogens and hydroxides in the water and tells us kind of the acidity of the water. And we also used a conductivity device, which told us the temperature as well as the minerals and ions in the water.
So, this was one of our first pieces of evidence. We decided to measure the different amounts of conductivity and pH in buckets of water, which we added different ingredients to. So, for example, on the first graph, you can see the yellow line. That's the conductivity of the bug spray. And this one, it didn't increase that much, but it still did have an increase, as you can see. We started with a conductivity of about 15 parts per million, and it rised up to 21 parts per million after 30 minutes. And our X variable was time, and we tested it at 0 minutes, 5 minutes, 15, and 30 minutes. The red and blue lines, those were the sunscreen and the lotion, and they had a more like a little spike in the beginning and they slowly increased over time. For the lotion, we started with a parts per million amount of about 15 to 16. And then after 30 minutes, we tested it again and we came out with 31 parts per million, which is quite a big increase in conductivity for the amount of materials we applied into the water. On the other graph, you can see the pH. This one didn't really match our hypothesis because, as you can see, the amounts didn't really increase at a steady rate. They kind of decreased, and one of the yellow one increased a bit. So we weren't really able to find a relationship in this graph.
And then here we have our bar graphs, which shows where we tested the water. So, for example, the dock, the swamp, the stream, the camp lake water, which was right next to our campsite, and then the buckets of water, which are the last three on the end, which are the lotion in the water, the sunscreen, and the bug spray. And then this kind of just compares the conductivity on the left to the last three, which is our materials that we put in buckets of water. And then on the right is the pH. And then the last three, the buckets of water. So you can see how on like pH, the swamp is kind of closely related to the bug spray. And our results kind of are similar to other areas of water.
And then also for every location that we tested, for example, the dock, we went to 3 different docks, and at each dock we collected 3 pieces of data to make sure that we had an accurate average when we averaged everything out. And because we had so much data in the end, we decided to create this type of bar graph because it clearly shows the averages and the correct amounts of our data. For our discussion, our main results were that conductivity of the water went up as we put the products into the water, and so did the pH, but not as drastically as the conductivity. We think that we saw this uprising of conductivity and pH because it led to worse water conditions. Um, we think that our results would compare to our hypothesis quite similarly because we thought that the water conditions would get worse as we added the ingredients in. And we found that the pH levels did not change as much as we thought during our testing. We thought that the pH would change more drastically because it is something that can get affected by water quality. And we found that the usage of human products affects the natural habitats and the environments around us in a negative way. And this is because if water quality decreases, then the organisms and the habitats and environments won't become as good for the animals and organisms that live in them.
And then for future research, we would love to continue our project, and then maybe we could test the water qualities at other places near us with more human pollution, like for example, harbors, popular beaches, and other lakes. We could also test for specific ingredients, which could prove how some bug sprays, sunscreens, and lotions would be worse for the environment than others. And that basically sums it up. Thank you for listening.
Thank you guys for a super interesting presentation. If anybody from the audience has any questions or any of your fellow campers, they can write in the private chat. But if anybody from Facebook or YouTube wants to write in that chat, I can add those questions to the presentation so that Amelia and Noah can answer them. I have a question maybe to get you guys started. Do you have any recommendations for users going to the lake? Like, would it be best not to use a certain product based on your research?
I think I don't think we're 100% sure, but materials like DEET and bug spray, which is pretty common, isn't so good for the environment.
And then also, since we weren't able to test like specific ingredients because we didn't have that kind of tool, we weren't able to find like which ingredients are better. But like based on what we know that like Noah said, DEET would be bad, and ingredients like maybe zinc in sunscreen would be better for the environment than maybe some spray that's consisted of all chemicals.
Very interesting. I don't see any questions in the chat. So thank you guys so much for a super interesting presentation. Yeah, thank you for sharing.
Thank you.
Thank you.
Great. So Claire and Maddie, let's give you guys another shot. Hopefully your computer doesn't freeze this time. So I'll add you guys. Let me know if you can talk and hear me.
Yeah, okay.
Yeah, we can talk now. Yeah.
Okay, great. So I am going to share your presentation as well. Just let me know when you want me to change if I haven't changed already. So
No problem. Yeah.
here
course.
we go.
Okay.
All right, guys, take it away.
So water quality in major fishing spots versus on the shoreline.
By Claire Cahill and Maddie Andrews. This is our project.
Okay. Next slide, please. Okay, next slide, please.
Next slide.
Is it working? Okay.
Okay.
So,
Um,
Oh, wait, can you go back, please? Okay, thank you. So our question was, what is the difference of water quality in major fishing spots versus by the shoreline? And our hypothesis was that the fishing spots will have lower pH and lower dissolved oxygen than the shoreline. Then that means that the water quality in the selective area, considering with the shore, is better as a whole. And we chose this question because we wanted to see the difference of water quality in the fishing spots where there's traces of motor oil and gasoline versus by the shoreline where most people just swim or pull non-motor boats into the lake.
Yeah.
Okay, next slide, please.
So for the methods that we used, over the week, we would watch the boats and see where they're fishing and if they're fishing and see where they go and the most popular spots around the lake. And then we would kayak out to where we would see the most boat activity. And then we would take a sample of each little spot and then come back to the shoreline and measure the dissolved oxygen and pH using the SparkView app. Then measure the dissolved oxygen and the pH at the shoreline spots that lined up with the fishing spot. And then we used the SparkView app as well. All 100 feet apart. And then we would mark everything down in the notebook.
Okay, next slide, please. And then these are just some photos.
Yeah.
Of the lake and...
Yeah.
Yeah. Okay, next slide, please. Okay, so at the fishing spots, we have 0.1 where the pH was 6.7 and the dissolved oxygen was 4.65. With the fishing spots, it ranged from 6.5 to 7, and with the dissolved oxygen, it ranged from 3 to 4.5. And this is the pH was all kind of the same, but the dissolved oxygen is different because fish need lower dissolved oxygen to survive better and thrive. And so since the dissolved oxygen is lower, that's bad for the fish. So yeah.
Yeah. And so for the shores, then we had... I'm talking, right. So for the shores, we had the pH was 8.6, 6.67, 6.5, 6.5, and 6.75. And the range was from 6.5 to 8.6, and then the distance from the shore that we would measure, the range was more about 4 to 16, and and then the dissolved oxygen was
the dissolved oxygen was higher in the shorelines. Okay, next slide, please. So this is the pH graph. So as you can see, it was mostly around 6 to 7 to 0.7, but there was one that went to 8.60, which could have been a malfunction, but it also couldn't have been, which means the water at that one spot was
quite was a little bit cleaner and less acidic.
Yeah. And then next slide, please. Then this is the dissolved oxygen. So it ranged from 3.8 to 5.2, and most of the data was around 0.5 or 4.5, but there were two that went down to 3.99, which is not that great because fish need dissolved oxygen to thrive.
Yeah.
And next slide.
And then for our conclusion, in conclusion, our hypothesis was half supported. So the dissolved oxygen is in fact lower in the fishing spots versus the shoreline, but the pH was both lower and higher, which meant the pH of half the hypothesis was not supported, which gives us the information that the shoreline was more acidic.
Yeah, so we couldn't come to a full conclusion on the pH because it was around the same, but the dissolved oxygen, in the fishing spots it was lower. And next slide, please. Thank you for listening.
Yeah, thanks.
Thank you guys for another really great presentation. I know you guys worked hard to collect your data, so we appreciate you sharing. If there are any questions from the audience, please feel free to write them in the chat. Or if any of your fellow campers have questions, they can ask too. Okay, so we have a question from the audience, so I'll show that one for you guys. And so the question is, how do you think these trends in dissolved oxygen and pH might change when measured on a different lake? Would you expect a lake with different human activities or different animals to be different?
Okay, so in different lakes, like say Lake Tahoe, it's a lot bigger. There's a lot more boat activity, and there's also jet ski activity, more kayaking activity. So there's just more boat activity with motor oil and gasoline. So there would probably be very different answers depending on where we are in the lake. If we're closer to more of like an inhabited lake with a bunch of boats, the dissolved oxygen would probably be a lot lower, and the pH would probably also be a lot lower.
Just knowing what we know from our experiment.
Yeah. Any other questions?
I'm not seeing any others in the chat. Give it a few more seconds, but I think that's all. Thank you guys so much. Thanks for joining tonight and sharing your results.
Yeah. Bye.
Bye.
All right, so next we are going to have Neil and Jonah present. I will add them here. Cool. And I will share your presentation. All right, guys, take it away.
Hello, I'm Jonah, and our presentation is about how water depth affects water quality. Next slide, please. So just a quick introduction. Our project includes oxygenation and TDS, or total dissolved solids. These are the two things we measured to determine the quality of the water in terms of the depth. And we measured these two things in different depths. Next slide, please. So a little bit of background. The reason we really started this project is to have a better understanding of how the water quality in the lake just sort of is, and also how different depths can affect this, and how the depths can range, and the difference in water quality between these depths.
Right, so our hypothesis was that the total dissolved solids would go up the deeper we go, and the oxygenation would go down the deeper we go. The impact of this research is that the impact that this research has is that it can contribute to other research, because using this research, it's possible to create an estimate about where a fish and other organisms could live by scaling the data. Next slide, please. All right, so our materials and procedures. To measure the quality of the water, we use an oxygenation meter. It's just something that an oxygenation meter is something that measures dissolved oxygen in the water. In addition to this, we use a TDS, or total dissolved solids tracker, which can trace the amount of ions and minerals in the water. It sends a small electric signal that traces it. We also use a transect tape to measure 100 feet between each site and a meter stick to measure the depth. To collect our data, we tested at a random site and tested 1, 2, and 3 feet deep in the water and used the TDS and oxygenation. We measured every 100 feet from one site to the next, and we went in both directions from shore 1. Next slide, please. All right, so these are our
The
graphs.
results from the TDS and the total dissolved solids sort of varied, and they went sort of up and down as we tested sites, and we found that some of the colder water, the solids would group up and sort of fall down to the bottom, and in some of the shallower water, we thought the solids might have grouped up in the shallower water and sort of stayed there, and there would be more in the shallower water, and it would sort of like drop in the sort of mid-range water and go back up as we got into deeper water. Yeah.
Oh, the dissolved oxygen. So the other thing that we measured was dissolved oxygen. Dissolved oxygen is the amount of oxygen in the water, and this can affect many things in the area. For example, any living organisms in the water. And we use this to measure, and we use a tool that is able to detect these particles and give us data. We found the deeper we went, the more oxygen is present in the water.
So the overall correlation was that the oxygen gets higher the farther down you go by about 10 milligrams per liter every foot. The TDS results we were not able to put in a linear path due to the fluctuation in our data in the different depths. So the conclusion is that our hypothesis was partly supported because we thought that the oxygenation would sort of go down a little bit and sort of in a path, and we also thought that the TDS would go up, but it ended up going up in it sort of fluctuated as it went up, so our hypothesis was technically not fully supported. Thank you for listening.
Thank you.
Thank you guys for another interesting presentation. If there are any questions from the audience, we are glad to take them. Okay, so here we have a question. Did you measure these variables at the surface of the water or at different depths?
So we measured these at the surface of the water, first of all, because the tools we had were not supposed to be submerged, and we thought that it would be we wanted to know how this would be at the surface of the water, because we knew that it would be a little bit different in deeper places, because the temperature would obviously get lower, and more of these and the temperature can affect some of these variables. And so we decided to start at the top of the water, because there would be a little bit less variation in the results, and also we already knew that it was going to be a little bit different. We didn't know exactly how, though, if it would be in colder water, but we were not really sure about how it would be at the top in these, and also this can help and this makes it easier for people to measure the water quality and figure out estimations and things for other research if we measure it at the top of the water.
Great. We have another question in the chat for you guys. Why did you choose a 100-foot distance?
In the beginning, we actually chose 30 feet. We then put it up to 50 feet because we then realized how much time it would take just to gather one site and then move to another one just to only gain 30 feet. Also, every 100 feet or so, there was an actual access to the water. And because of that, that was another thing that assisted in our decision to make it 100 feet. Because if we were going 30 or 50 feet, we would have to go through like a lot of grassy areas with an entry point which doesn't actually go all the way to the water. It'd be like a 2-foot drop or 3-foot drop or something, which would not really be good.
Also, we wanted to randomize our data and make sure that we weren't picking sites, and so 100 feet just ended up being a number that was good for measuring sites.
Awesome. Cool. Well, I'm not seeing any other questions in the chat right now. So thank you guys so much for working so hard on collecting your data and giving us this very nice presentation.
Thank you.
Thank you.
Great. So our next presentation is going to be from Ava, and she investigated some interesting relationships with toads. So we will add you, Ava.
You have my presentation?
Yes, I do.
Okay.
So I will share that. All right, take it away.
So my question was, does water temperature affect toad mass? Can you do that? Introduction. I did my research over the course of 4 days in the meadow and meadow stream near Rubber Lake. I did this so I could collect accurate information and answer my main question whether temperatures in a toad's habitat can affect its size. I was hoping to learn more about toads and their environments. This topic is important because it's relevant to climate change and the irreversible changes it has on our planet. Research question. Does the temperature of a toad's habitat affect its size? I added a little picture of a toad I had on one of the paths. Hypothesis. I thought it might affect their size because temperatures could be a stress factor to toads, especially since they are very sensitive to temperature changes since they are cold-blooded. Materials and methods. Methods. I collected my evidence while walking transects across the meadow and walking along the meadow stream. I also used gloves whilst handling the toads, and I have a picture of me handling a toad in gloved hands. Materials. I used a thermometer and a scale to measure the mass of the toads I caught. I also used the gloves as one of my materials as well. This is my graph. Unfortunately, there are no discernible patterns because I did not have a large enough sample size, so my data did not support or deny my hypothesis. Discussion. Unfortunately, my main results were inconclusive. I think this is because I did not have enough data points to create a strong claim. My results differed from my hypothesis if there wasn't a conclusion. My future research question was, do pollution levels also affect the toad size, not just the temperature of the water? And that's it. Thank you for listening.
Great. Thank you so much. I'm sure it was super fun to be able to collect some toads in the meadow. I have a question while we're waiting for other questions to come into the chat. What would you have done differently to get more toads this time around so that you could have a bigger sample size?
I think I would have done different parts along the stream. It appears that the toads seem to like the parts where there's bushes and there's water and there's marshy grass. All of those parts aren't along the whole stream because I found 4 toads and almost all of them were in the bushes.
Interesting. Okay, we have a question in the chat. Did you catch anything other than toads?
I caught a frog and I saw another frog. The frog was 2 grams. It was very, very little.
Cool. Okay, one more question here. Can you talk a little bit more about what the actual data collection process was like? Did you find it challenging, fun, both?
The data collection process was tiring because you have to be patient because the toads aren't just going to come to you like immediately. You're not going to go out searching for like 10 minutes and be like, look, I found 5 toads within 10 minutes. I mean, it took 4 days for me to find 4 toads, which is about a toad a day. So it's a very like hard process, but it was very, very fun and as well as challenging. But I enjoyed it.
Yeah, I'm glad you enjoyed it. It seemed like you were enjoying it, and it was fun to watch you get excited about catching a toad. So I'm not seeing any other questions in the chat right now, so I will thank you for another amazing presentation and for making our week at Weber Lake so interesting. All right. So our next presentation, and I believe our last, comes from Claire and Ava. So I will add them. Awesome. Can you guys hear me?
Yeah.
Yeah.
Great. I will share your presentation. All right, take it away, guys.
Okay, so we were studying macroinvertebrate health, which could lead to the determination of overall lake health. Next.
Our interjection. We started our research on Tuesday, July 12th. Our first location was in Lacey Creek, and we chose this question because we wanted to determine the overall health of Weber Lake, Lacey Creek, and Weber Falls. This is important because the health of different water habitats in certain areas, we can help, or we can determine the health of certain areas by studying the organisms that live there, which contributes to the entire ecosystem's health.
So our research question was, how do pH, oxygen, CO2, and temperature impact macroinvertebrates in different bodies of water? And originally, we thought that considerably higher or lower CO2, oxygen, temperature, and pH would impact the lake more than it actually turned out to impact the lake.
The methods we used was we collected evidence by testing the pH, oxygen, CO2, and temperature in each location several times, then seeing how many macroinvertebrates there were in the location and how many different species there were, and the number of individuals.
We used 4 different water quality testers, one for each variable, pH, oxygen, CO2, and temperature. We then connected that to an app on our phones and collected the readings. We also collected samples of dirt that we had disturbed to get macroinvertebrates into the net, then examined the samples, identified the macroinvertebrate species, and categorized them by intolerance or tolerance to pollution.
For our pH, we didn't see much of a pattern with it, but at our 6th site, which was in the lake by the beach with most people, so it had the highest impact of people, we found a higher pH of 8.2, where the rest of our readings were around 7, and we did find less macroinvertebrates there, or a lot less macroinvertebrates there than we had found in our other locations. For oxygen, we also didn't find any correlation of oxygen to macroinvertebrate health. So yeah.
For CO2 and number of being compared to number of individuals, we didn't see a connection, but that may have been due to equipment malfunction because our CO2 reader was all over the place and it didn't really we didn't think they were accurate readings. And then for temperature, we also didn't really see a connection between temperature and number of macroinvertebrates, but we did notice that most of the macroinvertebrates that we found were in the same temperature range, except for one outlier location, which was near the swampy part. We found a lot of little ones that we estimated to be around 50 plus.
Our main results, for the most part, were inconclusive, but there could be some correlation between our factors and macroinvertebrate health, but we don't have enough data to know for absolute certain. The results that we did see, though, we did see some correlation in some of or a small amount of correlation in some of our factors, but again, not enough to support a conclusion. And for the most part, the data that we did see, with the data that we did find, our hypothesis was supported because some of the higher and lower temperatures, we did find a little bit of correlation to our hypothesis. And we didn't really find a ton of unexpected stuff. Yeah.
So based on our findings, we think that if we could collect even more data around the lake, stream, and waterfall, it would help us find a more reliable trend among water quality and macroinvertebrate diversity in populations. But there also could be another variable that we could test for that could be affecting our data, like equipment malfunction or like human activity near the water. That's it. Thank you.
Thank you for listening.
Awesome job. Super interesting presentation. You guys had a lot of data, so it was really nice that you could fit it all into one little presentation. I have a question while we wait for some to come in the chat. You said in the future you might want to test to see if there was equipment malfunction, because that can obviously affect your data. How do you think you could do that?
We could we could use like different pieces of equipment and see if they give us more accurate readings. Like if we, like the CO2 monitor, we could have used a different one and seen if that one gave us like around like the same numbers instead of just like 0 one time and then the next time like 100,000. So.
Cool. Yeah, I mean, it's definitely a problem to have error in your machines. So any way to correct for that is great. We have a question from Beth. So what other variables might influence numbers of macroinvertebrates besides human activity?
Maybe the location of the site that we're testing. Like we found in the different locations that we tested, like we tested in the swampy area and the creek and areas like that. We did find different like categories and types of macroinvertebrates in each location. So like the location could, yeah.
Also, what was the coolest macroinvertebrate that you found?
We found one really big mayfly. It was like almost an inch long, which is very big for macroinvertebrates.
Yeah, in the stream we found a really big mayfly, and it was so cool.
Awesome. Well, thank you guys very much. I am going to remove you guys. And I believe that is the end of our presentations. I don't see anybody else joining that wanted to present. So thank you all so much for coming and listening to what our campers had to say. They all worked super hard, so it's super cool to see their rewarding data, and we all learned something from each other, and I think that's what's so cool about Science Camp. So thank you all so much for coming and for sending your campers to Weber Lake. We really enjoyed having them. And Beth and I are both around for the rest of the summer. And you guys are more than welcome to email us with questions, or if you have an interesting idea for a future project, we would love to hear about it. And I hope that you guys keep collecting data and stay intrigued by the environments around us. So I will go ahead and end the broadcast, and thank you for joining.